real exam questions. This is question 5. It's about ultimate limit state. And the question goes as follows. Prove the following expression for simple bending without compression reinforcement in domain 2A. It's this expression, or of course you can turn it around, then it will be that expression. They are both equal. And explain practically what you can do with this formula. Domain 2A means that the reduced bending moment is between those two numbers. It means also that the steel is yielding. The filling coefficient in domain 2A is 0.81 and the coefficient of center of gravity is 0.416. The reduced bending moment is defined as with this formula, and the mechanical ratio is also defined by this formula. Now let's look at transversal equilibrium. And in the transversal equilibrium, we have the situation when the steel is yielding. So when sigma s is equal to Fyd, then we know that omega is equal to psi times xi. And this is in fact the total force in the steel must be equal as the total force in the concrete, or tension equals to compression. The rotational equilibrium gives you, of course, the rotational equilibrium around the tension reinforcement gives you this expression. The transversal equilibrium, we said already, because sigma, the steel is yielding, we got omega is psi c, or we get c from this equation, which is omega divided by c. From the rotational equilibrium, we start with this original formula. This is the lever arm, and this is the total force of the concrete. So it's an equilibrium around the tension reinforcement. Now we fill in the value of C, which is the position of the neutral axis in the section. So we substitute. We know what the value of omega and delta G is, because we are working in domain 2A. So we plug it in, and we arrive at this equation. Now we can easily round it up within 1%. Instead of 1.95, you take 2. So this is the equation that we wanted to prove. Just bear in mind, if you want to calculate a little bit more significant, then C is 0.81, but in fact it is 17 divided by 21, and for delta G it's 99 divided by 238. So you can calculate this ratio, and it's 1.946. So instead of 1.95, but if you round it off, it's 1.95. So this equation allows you to calculate the resisting bending moment in domain 2A at a given reinforcement within a margin of 1% without the use of concrete tables. So this formula makes that you can easily in domain 2A calculate the needed reinforcement. Or you can calculate the resistance when the reinforcement is given. And it means mu d must be between those two values.